Okay, hello there, everybody. This is Mike Rowland in Central Kansas, and I'm here to show you my magnet motor and talk to you about step one. Step one is to take a magnet, four magnets, and cancel them. Now the rotor magnets have north on the facing out. And the object here of the outer magnets is to have them opposite so that one is pulling across here and the other one pushing, so that when they go around they cancel each other. In other words, when they get to this spot right here, they don't lock up. For instance, look what happens when I run this. See how this is off balance? Well, that's what we call it, but normally speaking, you see this magnet here is out of the way. I moved that. I got these on little pivots. So I moved this one out of the way. Cancellation is not working. So what I have is a north pole here and a north pole here, and it just pushes away constantly. See that? Get it past the middle and it pushes away and pushes back, and it's very strong magnets. See them there? And then the opposite is true of the other side. When you back this one out of the way and you put this one in place, it's constantly stuck over there because that's the attraction side. You can see that it's really stuck there. See it? It won't run freely, and when it goes around it'll get stuck there. See that? Okay, so the object is, this is the attraction side, not the rotor. The rotor is both norths. This is a south over here, so that's going to be attracted to this north rotor, right? Okay, so now we'll try to adjust these levers. You see these levers I've got on here? And put them where they're canceling each other out a little. See how it gets stuck there? It's still not perfect. So I got to keep adjusting these magnets until I get what's called cancellation. Now that's pretty good there. You see that? I can put that in all kinds of places and it's not stuck, and it's not pushing away like the other one. Remember how it pushed away when I get past a certain point? It'd go like that because it's dominated by the repulsion here, because the attracting magnet over here is missing. So you see, it's just sort of locked up. I'll be right out. Okay, so here we have one half of the motor, and this is the other half right here on this side. You'll see me bring the attraction magnet back in. Now if I bring this one too close, it's still dominated by push. See how it just gets on either side and it pushes over? Now they're close to each other, but they're not right. Now if I get it right, see, that's getting better now. It's not pushing so hard away, but it's still pushing away. And but if I keep adjusting it, I'll get to a place here that works better. Oh, there is a good place. See that? Now I've adjusted this and I've drawn lines, so I'm sort of cheating here because I know right where I need to be. Okay. Before I came here, I planned to show you that, but I drew lines on each side here so I can find it more easily. It took time. I had to move these around and then drill the hole, you know, and then lever action it out. But I just did this for demonstration. Oh, see, it locks up there? Now this side doesn't work. See how it just keeps pushing? But then this side works. Look. this side here works beautiful. See that? That's what I want. I want it to stay put without all that pushing away. I want it canceled. And this side is canceling. Both sides are working together and they're canceled. This rotor is canceled this way. But because my distance of my rotor magnets are different, when I come around here, you'll see that it's not canceled. See it pushing away? And when I get on the other side, it bounces. So that's no good. So I failed. But I did learn that the distances from the center have to be precisely, exactly within, you know, a few thousandths of an inch, really, when you think about it, because see it there, this side works. You see that? See how that works? So there's no resistance here. Watch. See it just stay wherever I put it. But now this side don't do that. It'll come back if I don't get enough force, and then if I get enough too much, it'll go past with clunking. See it clunk back and forth. So I learned a lot with this, and I wanted to start with step 1, and I have not achieved step 1. Step 1 requires that when I spin this rotor, it acts like this on both sides where there's cancellation. You see that? So I really wasn't thinking about it enough, and I would cancel it, or think I had cancellation, because one side was, and never really thought about the fact that, you know, when I spun it up, that it really wasn't effectively done on step 1, because I got to this other side and I realized, hey, I thought I was done here, but, and then I thought, well, maybe my magnet was loose, so I tightened that up, make sure it was tight on both sides. There, it's tight. Now that side worked, see? And then I was thinking about my ramps and all these different things that I'm doing, brackets, mounting and stuff, but I realized that just because I have cancellation on one side does not mean it's cancellation on the other side. So now, and these round magnets are wrong anyway for me. I'm planning to use these or bigger. These are really powerful. I think I'm getting like about a 50-pound pull force with these. And these are only 30 or 40, 30 I think. These are kind of little. I put masking tape around mine, a lot of my stuff there, my magnets, so they don't get shattered. Now this is the ones I'll be using, and you know, if I wouldn't have had that tape on there when that slammed together, I might have cracked those magnets. But I'm not cracking them because I've got them protected. See that? And you can bite your finger there with those things too. They're so powerful. But these are square, and they did come in the mail. I got a box of them over here. And I noticed that even just, we'll get back to cancellation here, but even, let me switch gears here for a second with my ramps and my magnets that I will be using. I took a piece of metal, and I'll just take a pair of pliers like this, and I'll set this magnet down, and put it on there like that. You can feel the pull force on that. So it's hard to tell, but I did it with another piece of metal that wasn't quite covering it all, and I felt it like that, and then I turned it over and I could tell a difference. So I need to set up what I'm trying to say is that I need to set me up a way of measuring these, and a couple of the guys on the group have already shown me how to do that. But you can feel the pull force on one side might be a little smaller, so I'm not sure really if it is or isn't. And so I was trying different smaller things, like here's a small nail. You can feel the pull force on that, and then if you turn it over, it feels stronger, maybe a little on that side than it does this side, by a little bit, you can tell. So it's important that you get also not that only the distance of the magnets perfect from center, but that you get magnets that are about the same strength. Because in this video, what we're talking about is rotor failure. This rotor, I just glued it in right here, and it should have adjusters now, I realize that now. But I just glued that in with epoxy. And I thought I had it pretty close, you know, but evidently not enough. Now you'll see it stays wherever I put it. It just stays wherever I put it on this side. But if I try that on this side, it don't stay. See, I get it up here and push it on the other side of the sticky spot. It's got a sticky spot here on this side. So you see this is rotor failure. But on this side, it's working, see. So for me, this is a success and a failure at the same time, because I'm learning to understand what step one is about. So then I'm gonna, this is just a turntable bearing, and it's real floppy when you get it under pressure. When you get this rotor, see that rotor? You probably can't see that rotor, but it flops like crazy. It flops all over the place, see that? And so when you put ramps up to it, and then these ramps are real floppy, you see that? That's no good either. But they were okay for testing. These ramps are to go on here, and you'll see though, this is the good side. You see it accelerates a little bit there. But I don't have a good space here. Another thing is about this cut is that my magnet is way in from the edge of the rotor, so I can't bring the magnet, this magnet, close to that magnet, like within a few thousandths. You see what I mean? I've got an inch or so in there. So that's no good. And even though I've learned cancellation, you know, and the rotor failure and stuff, I don't consider this a failure, because I'm learning what is meant in the subject, you know, what Mac is showing us. So what I need is I need a rotor with magnets that go out to the edge. They go all the way out to the edge. Say if this were the rotor, I need it to go all the way out to the edge and crooked or whatever, have it adjustable this way, and also this way and this way. It needs to adjust, so I can get my precise cancellation for step one. So what I got in the mail was the magnets, and I also bought some things to make a rotor. I'm going to show you. I bought some of these stainless steel washers. They're really thick. They're for the bottom of lamp stands, like stand-up lamps. They're real thick and hard stainless, hard to drill, and you don't want to weld them. They warp up easy. Because see, I took a collar. Here's my collars I got. By the way, I got 5 of these for like $10 shipped, and that I considered that pretty cheap. And I'm showing you a hub that I'm making without spending $500 for it, or $1,000 or some crazy thing. You can't even buy a hub or for this kind of or anything. You can't without going to a machine shop and having them reinvent the wheel. So anyways, I had this and I had this, and I thought, well, that's a good step, you know. I could get that to that. So I tried that. I welded it to there, and it warped the crap out of it. Then I took it on the lathe and tried to get it to to polish down, and it didn't work very well. The welds were, so here's what I ended up with. I ended up with a job well done a different way. I didn't mess up the rotor, I mean the washer. Here's that's my good one, and I'll show you my failed one first. These are my colors, a whole $1 a piece for a color, right? Not 500. And here's the failed one. Now the failed one is not very far off, right? Excuse me. Anyways, when you lock it on and you turn it, and I have like a bushing here that I slide on there for testing. When you turn it, it wobbles. When I set it up and put an indicator on there, that wobbles. And when I lay it flat on something good and flat, it wobbles. You can see it wobbles there. I thought, wow, just those 2 little tack welds on there, that warped that whole piece. Throw it in the garbage, right? That's all it's good for. So that's why I bought multiples. So I got another one out, and I drilled that hole, which was really hard to drill without the right bit, you know. I just have regular standard steel bits, and it cut right through. With a lot of chatter, I had to sharpen it. And then I took that and got it onto the shaft, and I got this on. This is a shaft out of an air conditioning motor, or any half-horse motor. They all have the same half-inch shaft. It's all universal. There are a million of these you can get. But you can't find a hub for cheap. You want to spend $100, $200, go ahead. You can find a hub maybe for it, just like you want it. And I'm not into that. So I took a collar and a washer that was really perfect. I mean, these babies are thick and strong and perfect. And if I don't mess it up, right, I got a perfect hub. Well, I got to drill 4 holes in it, because I'm going to be putting a piece of round acrylic. That's in the other room. I can show you that too. But what I'm showing you now is my plan, and so I got that in the mail, and this is what I ended up with. This is this piece drilled out, put to that piece. Then those are stainless steel bolt and nut too. Like for your heavy duty heat sinking. I just drilled straight through this soft collar and that little space there in the stainless and countersunk a little. And now I have a perfect, I mean to tell you, when you put that on there, and you know, I run it in the lathe or the drill press, and it really is nice. It really is smooth and even. So that's what you need, because and this is where this is going to go, here, right here, see? Well, it's not going to be on this test platform probably. I don't know. This is wood. I'm going to convert, and then this is going to go here. I got the bearings coming in the mail, and then this collar, this piece can go here, and this can handle a pulley. Right here, there's a notch there. You can see it maybe, and the pulley goes on there if if I can get it running. But right now, I'm trying to figure out ways to get a good solid bearing on there. So I got to trim these off, these little ends, and put this second collar. Then my bearing goes on here, and I'll have 2 bearings right here. Now I'll have a real solid table there. I'll have a real solid turntable that won't wobble on me. And I might have to go to bigger magnets. I don't know. But these little bitty magnets, I don't know. I really don't, guys. Those are kind of small. But if I have enough cells all around the circle, it should work fine. And I'm going to do some testing with these, and try to get this to work with that size wheel, because I think that when this little tiny magnet right here and this bigger one are coming close together, man, we're talking, wow, we're talking about 50 pounds of pull force to get that off there. You know, that's powerful right there. I can barely get that back apart, and that's how I got to get it to working, right? So I'm gonna get this one will be here, and then this one will come around, and then I'll have those ramps on there like this, some kind of ramp here. I'm gonna discontinue these, but I'll have a shorter ramp probably, and so, you know, I can fit 6 or 8 of cells, or 6 or 8 of these around the circle, which is plenty enough, strong enough right there. Wow. And see, that's the whole problem. When you get it that strong, that rotor wants to flop. See that? And it can't be flopping all over like that. So I'm trying to make a stronger rotor shaft and bearings, so I don't get all this flop out at the other end. And that does have a big influence on how it may fail or not. So I'm working on the mechanics of it. It takes time, and once somebody does it, it's easier for the next guy. Now you can buy this on eBay for $1, right? And this for $1. And then you can drill holes, like I did, right directly through there, and you're going to have a perfect hub for a 1/2 inch shaft if you can drill that out with a drill press. Because this is already machined stuff. This is already ready to go from a machine shop. But the question is, how do you get this on there? And everywhere you look, you can't find a hub, you can't find a working hub for cheap. This will stop you up. Excuse me. Finding a hub is impossible that I can find. I have not found. They want to charge you, you know, an enormous amount for a hub. So now you got a way to make a cheap hub, and then the pillow block bearings will go down here. One here, well, there'll be a collar and locked on to keep it from falling down. When you slip it, it'll just fall down in there. There'll be one small bearing here and one small bearing there, and so that'll hold that really strong. And then your acrylic disc goes on, sits on the top without all that flopping, and you have a way of locking it down. Because we've been told by Mac, excuse me, I got a tickle in my throat today. We've been told by Mac that there's a feeler gauge. You got to put a feeler gauge in there, and you can see that there's no way. There's the distance there is 1 inch or more that I'm going to get a feeler gauge in there. But I'm telling you what, when you get that much pull force near a magnet, and it's really going to play on your bearing, so you need something solid. Alright, and that's about it. I just wanted to show you that I did manage to get, not on this side, I got cancellation, but not on that side. Look at this side though. See? Perfect cancellation. No matter where I bump that, no matter where I put it, it stays there. See that? It doesn't run away on me. And if I come back here and push it around, it just barely floats through there like that. You'll see it slow down. You can see there's an air, if you want to put it that way, of magnetic cushion there, but it's not forcing it around. See, it's not making it go one way or another like this. See that jerk? So there's something important there for you to see. Because for a while there, I was wondering if I was ever going to get cancellation. But I suddenly got it, see? And that's a key to making these motors run. Now this is not a motor, this is just a single cell, and you need 6. I'm sorry, you need 3 or 4 of these. You can go as many as 3, which would make 6 points in the circle, or 4 of these would make it 8. 8 outer and 8 rotor magnets. Okay, so cancellation can be had there, as you can see. And then your now your ramps. Here's a ramp. This is a ridiculously big ramp. I hope you can all get a good laugh out of that. You see how big that is? At least I thought it was ridiculously big. But the way that's supposed to go is above and below the magnet. Now what I learned was when you put a lot of metal there, I was also trying to space these round magnets up a little. Put something like this around that round magnet so that the ramp would be above it or below it, but this ramp is impossible to bend. And I'm just wanting to show you, as a matter of fact, kind of a thing, that the ramp induces the magnet in that rotation, and then it locks again. Where before I had cancellation, see? So as soon as I get a ramp on there, now the cancellation's not working. It's locked again until I get something over here or adjust it to get balance again, because now the center is more over this way. The center of, so it's all a game of adjustment. You've got to be able to move this magnet, this magnet, this magnet, and this magnet. All 4 of those magnets got to move. And you got to be able to move them this way and this way and this way and this way, so you can get what you want. You can't just glue something in there like I did and get it to work. See that? It's stuck. So now if I want this ramp to work on this side by itself properly, first of all I need it close enough, which it's a mile away, and then I need to perform a sort of a cancellation right here where this is at. Now whether I can go adjust them out and adjust them in and get that, see how stiff that is? I got to work at that. See how it wants to go by more? See it wants to go by a little maybe? It's drawn in, and there's a cancellation point, and you can feel the pressure relief if you keep adjusting it. You'll see that it ramps and is more lazy. It wants to pull past, but when you get it closer and you get your ramps above and below the Y ramp here, and not so much mass and the right shapes, like here's that one. Let me show you this, another one, some other ones. Now when I didn't have so many ramps, I was using these pliers. It's the same thing, you know, but it's not shaped right. In other words, there's a big mass here and there's a Y. It branches off, right? So theoretically you could put this above and below that magnet and do some ramping with it. See it move? Excuse me. Of course this does not work as good because it's not shaped right, but it will. Just any metal will pull in. Now here's another one I was trying with. I was trying to get to the back side of this magnet and still have metal up near the rotor magnet and steal some flux off the back of that magnet. See, and still get the ramping done. As you'll see, it'll begin to pull in. But then it sort of stops out here. This does not work as good is having it near the front. Now I've tried it, at least with these Ys, it doesn't work as good. And keep in mind, this is the repulsion side. Excuse me. You see that right there? Now that's on the front side of the magnet. And so see these are some of the tests that I'm doing. At least this one wants to pull forward more. And I've lost my cancellation. First I need to go ahead and get that back again, because this is less mass. If you'll note the difference in mass here, this one is really heavy and this one's just a few mils thick with tape on it, kind of floppy, but it works good. Now I gotta find cancellation again. That is pretty close, and like I said, I got a cheater line here. I'll get it back quick. There's where I was at, right there where I was. And this is the good side. So this is pretty much as far as I've gotten, and you'll see this begin to ramp here like that. See it go twice, goes there and it goes there, but it doesn't go past. But it does a lot better. It's a lot less sticky than that big ramp. I mean, to tell you, that thing makes it really stuck over here. So I got less mass. I still got the same effect of ramping, but it's not so sticky over here, and depending on how I angle it. But it does throw off and if I bump this, I'll really be in a mess. But this is the far as I've gotten so far, and it's a huge distance in between there. See it want to pull in. Now UFO, he's got a video, a few posts before this, and so does Christian, and theirs are really close to each other, and they've got ramps that are really perfect. They're shaped properly this way and this way, and they're not floppy, and they're above and below the magnet in here with the perfect space through experimentation. Some are like this, some ramp like this better because they can catch the mass here, but then you need to spread these out over and above the magnets to get them to pick up flux from the magnet, like this magnet. If you hold this magnet in between these like this, you'll feel a tremendous pull force. It wants to stick to these two sides, and that's where it needs to be. It needs to be above and below that magnet, and there's pull all the time, which means there's flux traveling in here all the time. And now Christian made a statement that these individual legs are split by a piece of plastic. He put a plastic in between his, so there's two paths. The way he talks about it is there's two paths that it's traveling. All right. So, and again, you have one over here as well as the other side. All right. So here's some ramping on that side, if it will. I haven't fooled with that side. It seems to throw it off dramatically over there. I have, but I haven't prepared for this video for that. But so you'll see that this side does ramp around and it gets stuck right there. And so I'm looking forward to a less floppy rotor and more adjustment on my magnets and everything. So this is going to go out. I don't want this board here anymore. It taught me what I need to know, and this thing is going out. And I'm going to I got some plastic, some real high-grade plastic, and some more professional parts to work with now. So I'm going to move up to a more precise design. And then I'll be back to show you my new one. Alright, so that's pretty much it. I wanted to show you my ramps. Here's some of my ramps that I've tried. I've tried, like I said, the back side, trying to steal some flux here, and it doesn't want to ramp and let go. It wants to come back, stuff like that. And of course I haven't done every test. And you might have to, I seen Christian doing it, it worked fine, but his were above and below there, so I had to make a provision for the space too on this next platform. There's not enough space under here to get above and below these magnets right. So that's another issue. But all in all, I have found that they still induce, here's an adjustable one that I had, they still induce a flux path even though it's north and north here, and I'm taking some north off of here and putting it down the ramp, it still pulls, see? But right here it pushes. This pushes it away. But with the ramp you would think, well, it was stealing some of that north and see it pull? And that it would push it away. But it's not. So I've learned that it actually induces, no matter which side, you know, the front side here is best to induce, to ramp with. Now this means nothing. Running this around and around, that doesn't mean anything. What we want is to get it up near there, this magnet up near here, and then once it's in that pole, then it kicks it out over on this side. And then I'll have another one here, and it'll do the same thing. It'll kick it out on the other side. See? And I haven't reached that point where it kicks it out yet, because I'm not close enough. I don't have enough power there. And don't have a close enough tolerance parameters there to utilize the magnetic flux the way it's supposed to be used. And I don't have enough ramp mass close enough to utilize all that strength. Now watch what happens when I put a big, see how much power that big piece of metal has? See how much power? Now if that were ramping around, if I reach cancellation here every time and I had this much power and there was nothing resisting it here, think of all of the forward momentum I'd have. See that? What I'm doing is I'm taking that away, and I'm going straight up. I'm going straight up with it like that. Now watch what happens. Oops, I'm getting stuck on everything. I've been playing with it like this too, and I know a lot of people have done this over the years. And there's a lot of different ways, I'm sure, to get magnet motors to run. And you could just spin these up and get that to induce. But you need it close. And when you get it that close, it's going to want to pull your hand into it. You need it stationary. See it go around? If I pull it up just in time, and I'm utilizing some of this flux out the back of this magnet too. See it there? But another issue about these ramps is that I'm pulling it away, right? It's working, right? You can see that it has some pull force, even on the bad side. It has a lot of pull force, you see that? But the problem with the ramps are that if you don't have the taper, well, this is out, alright? But you do see that this was straight at one time. I wanted to show you my experiment, so I left it this way. But you see, originally I had this straight, and it was, see this taper? It was straight and it was tapered. which you want the flux to be induced into the points so that, you know, the heavy metal is really drawn hard there to it. But when it gets here, it wants to stick right there. See? It's locked right there because it's too close. It's interfering with the cancellation field. Now it's less here. So you have to experiment with ramps that do not throw everything off and do not affect the cancellation so dramatically. See, it cancels right there if there's no ramp hooked. But as soon as you get some metal around it, it changes and influences the whole, it imbalances it. And I found that the back side does not work for me as good as the front side. And even though these are short magnets, I still know the difference from listening to Mac and to UFO and Christian and Randy and Want to Make. He's doing it too. So I got it around the front now, see? Now if I touch these, if I just let this touch that, then it's all locked up. It's all messed up. But what I want is I want it above and below so that it's not so affected. See, it's less affected when it's above, but yet I still got plenty of flux. Excuse me. So I got plenty of flux if I'm of enough mass here, and so I can get this to pull hard here but let go here. So it's been suggested that we cut this down to a point and we get the distance above that magnet right. Another suggestion is to take the leaves on the end that are narrower and put some plastic in between them to make it less dense. And I've done that somewhat by cutting off some of the layers right near the end, and I need to make them pointed or whatever. But see, this is all floppy. This is just test. I need that solid. I can't have that. You see what I mean? I need it like this at least. I need to do like UFO did and build some nice heavy steel and get the contour correct, not this kind of thing. Get it up close and at least accomplish what UFO has done. UFO is really leading in the way. He's amazing. His results are amazing. He gets it up near the field here, and it just boom, it goes right past, you know, and it does it again, boom, you know, it does it twice. So you know, and it stops. It does stop. But the point is that I would love to reach that place where it, you know, at least as good as UFO has done it, and Christian too. And so that's what I'm working toward, and I'm starting to perceive the right way to go about it. And I just thought I'd let you guys know about my hub and how to make a hub and how to make it cheap without it costing you a fortune just for one little piece like this. Alright? That's it. I'll talk to you guys again when I change this board.